Aylesford Newsprint welcomes you to CDI, the presentation medium of the future. Thank you for taking the time to learn about the company and its 100% recycled premium-grade newsprint product, Renaissance. If you click on the Aylesford News button, you will start a shortened demonstration version of the whole £250 million project, which lasts about 5 minutes. You can find out more about a particular subject by clicking on the appropriate headline button. If you wish to see the presentation without an audio narration, click on the mouth symbol before starting. If you need any additional help, just click on the question mark button. The new fibre preparation plant will have the capacity to handle up to 500,000 tonnes per annum of waste paper, which, after taking account of losses of fibre together with ink and other contaminants during the de-inking process, will be sufficient to feed both PM14 and an expanded PM13. The new plant has been designed taking into account the mill's 25 years' experience of de-inking, which includes 12 years of using 100% de-inked fibre, and the experiences of others in the industry. Extensive trials with the proposed system demonstrate that there should be a marked improvement in the quality of pulp compared to that from existing plants. If you want more information on the process stages, please click on the appropriate coloured area. On its arrival at Aylesford Newsprint, waste paper, made up of 70% newspaper and 30% magazines, is held in an enclosed storage facility. It is moved as soon as possible into the new £40 million fibre preparation plant, which will have the capacity to process up to 1,400 tonnes per day of recyclable fibre, sufficient to feed both PM14 and an expanded PM13. The waste paper is mixed with preheated water in 2 horizontal rotating perforated drums to separate the fibres. With the water, common chemicals are added to create conditions conducive to ink release and to perform non-chlorine bleaching. This form of pulper achieves effective separation of fibres with minimum disintegration of contaminants. The pulp is diluted and mixed with a fatty acid soap, then pumped to a series of primary de-inking cells. Here it is aerated, and due to the hydrophobic nature of most inks, it collects on the surface of the soap bubbles. Ink sludge forms on the surface of the cells and is removed mechanically for disposal. There are 2 flotation stages with mechanical disintegration of residual inks in between. De-inking uses significant quantities of water, which becomes contaminated with fibre, chemicals, fillers and ink. Most of this wastewater is cleaned in a flotation plant local to the FPP and recycled. 5 million litres of water will be recycled every day. The sludge separated from the water, together with the sludge from the de-inking cells, is dewatered in screw presses to about 40% moisture. The resulting cake is burnt in a specially designed fluid bed boiler to raise steam. The clean pulp is thickened to 12% consistency and treated with acid to achieve a neutral chemical environment, and pumped to one of the 3 high-density storage chests prior to use on the paper machines. Each chest can hold 240 tonnes of fibre. The newsprint manufacturing process rearranges the fibres resulting from the de-inking process into an even, flat web and removes the water contained in the pulp to create a new sheet of newsprint. The PM14 contains a Valmet SimFlow head box with an HS speed former, a Sim2 press section with a fourth press, and a dryer section containing 7 dryer groups, an Aquatrol moisture level control, and a Valmet OptiSoft soft calendar with an OptiReel jumbo reel system. If you want more information on the process stages, please click on the appropriate coloured area. In the winders, jumbo reels are unwound, slit to width, and rewound onto individual reels with diameters and internal tensions specified by customers. 2 winders will be required to match PM14's output. The finished reels are then transported to an automatic wrapping machine. The OptiReel enables batches of finished paper to be transferred from the machine onto jumbo reel spools without halting production. The newsprint automatically starts winding onto a new empty spool when the previous one is fully loaded. PM14's jumbo reels will be about 2.7 meters in diameter and capable of holding about 40 tons of newsprint. The final stage of newsprint manufacturing is paper surface treatment. This is achieved on PM14 by soft calendaring, which applies pressure and temperature successively to each side of the newsprint web. This is a recent development in newsprint manufacturing technology that provides a given surface treatment with less loss of caliper than other methods. The paper web is finally dried using steam-heated cylinders and vacuum turning rolls. Water evaporated from the newsprint is removed by enclosing the drying section and controlling the extraction of air. This also enables heat to be recovered by passing the hot exhaust gases through a heat exchanger. The paper sheet is formed here by evenly distributing a fibre-water suspension across the width of the machine between 2 moving bands of woven plastic mesh. The water passes through the mesh and the fibres are retained and form a paper web. The formed wet newsprint web is partly dried and consolidated by being squeezed between 4 successive pairs of rotating rollers. Continuous felt loops both transport the newsprint web and carry away water pressed out of the sheet in the presses. An advanced water supply and effluent treatment plant has been included in the plant at a cost of £20 million. Water will be returned to the River Medway cleaner than it was taken out. The whole Aylesford newsprint plant will operate to the highest environmental and quality standards, a fact recognised by the UK government, which has contributed a £20 million grant to the project in recognition of its economic and environmental significance. The wastewater burden is well below regulation levels, both in terms of solids suspended in the water and biological oxygen demand. Despite a rapid and continued rise in production output, the wastewater burden has been markedly reduced in the last 20 years, and will not rise with increased manufactured output in the future. Despite a considerable rise in output over the next few years, the landfill burden will diminish as sludge is combusted as an energy source. Currently, the resultant ash is deposited in landfills, but in the future it is intended that this ash will be recycled into bricks. Aylesford Newsprint welcomes you to